The procedures for solving linear inequalities in one variable are much like those for solving linear equations. However, there are two important exceptions. When each side of an inequality is multiplied or divided by a negative number, the direction of the inequality symbol must be reversed. Here's an example below. If I start with negative 2 is less than 5 and I multiply both sides by negative 3, the only way this inequality stays true is by flipping the inequality sign the opposite way. Let's try some examples together now. Here I have this basic inequality. I'll solve it just like an equation. Start by subtracting 2x from both sides. I have 5x minus 3 is less than or equal to 7. I'll add 3 to both sides. 5x is less than or equal to 10. Divide both sides by 5. And now I do not flip my inequality sign because I divide it by a positive number. X is less than or equal to 2. So if I want to graph this on a number line, this is going to be an unbounded interval. 2 is my endpoint. I want less than or equal to 2, so I put a bracket, and then I shade everything to the left towards negative infinity. Here in our next example, we have some fractions. So I want to find my common denominator. The only denominator I see is 3, so that's my common one. I'll multiply this entire inequality by 3. That makes 6 minus 5x is greater than 3x minus 18. Now that I've cleared my fractions, I will go ahead and solve. For me, I like to keep my x's on one side of the equation, usually the left side with inequalities. Negative 3x on both sides. And I have 6 minus 8x is greater than negative 18. Then I subtract 6 from both sides. Let me bring my work up here. Now I have negative 8x is greater than negative 24. Divide both sides by negative 8. And now, since I am dividing by a negative, I need to make sure I flip my inequality, and I will have x is less than positive 3. And this problem is not asking us to graph, but let's go ahead and practice. 3 is my upper bound. Everything less than 3 means we would have parentheses on 3 and shading all the way towards negative infinity, this unbounded interval. Last one on this page, solve and graph. This one is called a compound inequality because this inequality is compounded in between these two endpoints, so I'll solve the middle. I'm going to subtract 7, but if I subtract 7 from the inside, I have to do it from all 3 sides of this inequality to keep it balanced. And that makes negative 6 is less than 2x is less than 4. Now to isolate x, divide everything by 2. Negative 3 is less than x is less than 2. So now if I want to graph this compound inequality on a number line, it's bounded by negative 3 and 2. We are not equal to those, so we have parentheses on those ends, and we shade everything in between.